in section 9.2. This is actually the last, that's not section 9.2, this is section 6.2. This is actually the last section that we're covering in this semester. So this will be the last of the new material you need to think about. We're factoring trinomials of this form, x squared plus bx plus c. So to get there, let's look to see what happens when we simplify this particular binomial, or this product of these two binomials, x plus 3 times x minus 7. Well, if I'm just multiplying these together, I get x times x, which is x squared, x times 7, which is negative 7x, 3 times x, which is 3x, and 3 times 7, which is 21. We end up getting x squared minus 4x plus 21. I want to look at how this compares to how this negative 4 and the 21, how those relate to this 3 and the negative 7. Well, you'll note 3 minus 7 is equal to negative 4. 3 and the negative 7, those give us the negative 4. You can see we get the negative 7 here and the positive 3 there. That gives us the negative 4 there. This 21, we end up getting, oops, that should have been minus 21, shouldn't it? This negative 21 we got when we took 3 times negative 7. 3 times negative 7 equals negative 21. So 3 plus negative 7 is negative 4. 3 times negative 7 is negative 21. Those are the two numbers we end up with here. So, and if we did this in general, if I did x times x, this would be x squared. I would get x times n. I get m times x, that's this one right here, and then m times n. Oops. Yeah. These two, in general, these are like terms, so you'd combine them together. This would be m plus n times x. This right here is b. This right here is c, when we're saying x squared plus bx plus c. So, how this is useful is if I have something like this, x squared plus 7x plus 12, and I want to factor it, that means I want to write it as x plus m times x plus n. I want to write it in this form. But in order to know what these numbers are the two numbers that such that m plus n is equal to b. You can see m plus n is equal to b, that's 7. And m times n is equal to c, that's 12. So I need to find two numbers whose product is 12, but whose sum is 7. Now I start with the product in general because there's a lot shorter list of numbers whose product is 12 than numbers whose sum is 7. You know, to get a sum of 7, you could go of course, you could do the basic things like 3 plus 4, but keep in mind you could also do, I don't know, 17 plus negative 10. That has a sum of 7 as well, so that's a rather long list. Technically, you could do weird, 1/12 times 144 could give you 12 here as well. But for our purposes, we're just going to be sticking to integers. And so if I'm saying what kind of integers, what kind of actually whole numbers could I multiply together to get 12, well, this is a much shorter list. I could do 1 times 12, I could do 2 times 6, I could do 3 times 4. And that's actually an exhaustive list right there. Those are the only ways I can multiply two numbers together, two whole numbers together to get 12. And now what I'm going to do, since I have this list, I'm going to look through the list and say, okay, do any of those pairs of numbers give me a sum of 7? Well, here the sum is 12, here the sum is 8, here the sum is 7. These are the numbers I'm looking for. So if one of these is 3 and the other one is 4, x plus 3 times x plus 4 are actually the numbers that I'm looking for. I can double check this by just multiplying this back out. X plus 3 times x plus 4. Let's see, x times x is x squared, x times 4 is 4x, 3 times x is 3x, and 3 times 4 is 12. So I get x squared plus 7x plus 12. And that is exactly what I started with here. But of course I'm trying to factor this, which means I need the last operation to be multiplication. And I also need each of these individual factors to be broken down as much as possible. And that's what's happened here. X plus 3 times x plus 4 is the factored form of this.